Assalamu alaikum. The Smart Schools Computer Lesson Class 5 Video Lesson 1 Chapter number 1 Evolution of Computers. In this video, we shall cover the topic Evolution of Computers from chapter number 1. You can read from page number 5 to 7 from your textbook. Before watching this video, you must be ready with the following resources: online with Smart Computing Book 5, pen, loose sheets, notebooks. Dear students, I hope that you have already arranged these things with you. By the end of this lesson, we shall be able to describe the early calculation devices, discover the contribution of Pascal, John Napier, Leibniz, Joseph-Marie Jacquard, and Charles Babbage in the field of computers. Before continuing to this lesson, we shall watch this video carefully.
Hi, thanks for tuning into Singularity Prosperity. This video is the first in a multi-part series discussing computing. In this video we'll be discussing the evolution of computing, more specifically, the evolution of the technologies that are brought upon the modern computing era. The purpose of this video is so we can appreciate how fast technology is evolving and the people who have brought us to this point. Many inventions have taken several centuries to develop into their modern forms, and modern inventions are rarely the product of a single inventor's efforts. The computer is no different. The bits and pieces of the computer, both hardware and software, have come together over many centuries, with many people and groups each adding a small contribution. We start as early as 3000 BC with the Chinese abacus. How is this related to computing, you ask? The abacus was one of the first machines humans had ever created to be used for counting and calculating. Fast forward to 1642, and the abacus evolves into the first mechanical adding machine, built by mathematician and scientist Blaise Pascal. This first mechanical calculator, the Pascaline, is also where we see the first signs of technophobia emerging, with mathematicians fearing the loss of their jobs due to progress. Also in the 1600s, from the 1660s to the early 1700s, we meet Gottfried Leibniz, a pioneer in many fields, most notably known for his contributions to mathematics and considered by many the first computer scientist. Inspired by Pascal, he created his own calculating machine, able to perform all four arithmetic operations. He was also the first to lay down the concepts of binary arithmetic, how all technology nowadays communicates, and even envisioned a machine that used binary arithmetic. From birth, we are taught how to do arithmetic in base 10, and for most people that's all they are concerned with, the numbers 0 to 9. However, there are an infinite number of ways to represent information, such as octal as base 8, hexadecimal as base 16 used to represent colors, base 256 which is used for encoding, the list can go on. Binary is base 2, represented by the numbers 0 and 1. We'll explore later in this video why binary is essential for modern computing. Back on topic, progressing to the 1800s, we are met with Charles Babbage. Babbage is known as the father of the computer, with the design of his mechanical calculating engines. In 1820, Babbage noticed that many computations consisted of operations that were regularly repeated, and theorized that these operations could be done automatically. This led to his first design, the difference engine. It would have a fixed instruction set, be fully automatic through the use of steam power, and print its results into a table. In 1830, Babbage stopped work on his difference engine to pursue his second idea, the analytical engine. Elaborating on the difference engine, this machine would be able to execute operations in non-numeric orders through the addition of conditional control, store memory, and read instructions from punch cards, essentially making it a programmable mechanical computer. Unfortunately, due to lack of funding, his designs never came to reality, but if they had, would have sped up the invention of the computer by nearly 100 years. Also worth mentioning is Ada Lovelace, who worked very closely with Babbage. She is considered the world's first programmer and came up with an algorithm that would calculate Bernoulli numbers that was designed to work with Babbage's machine. She also outlined many fundamentals of programming such as data analysis, looping, and memory addressing. 10 years prior to the turn of the century, with inspiration from Babbage, American inventor Herman Hollerith designed one of the first successful electromechanical machines, referred to as a census tabulator. This machine would read US census data from punch cards, up to 65 at a time, and tally up the results. Hollerith's tabulator became so successful, he went on to found his own firm to market the device. This company eventually became IBM. To briefly explain how punch cards work, essentially once fed into a machine, an electrical connection is attempted to be made. Depending on where the holes in the card are, will determine your input based on what connections are completed. To input data to the punch card, you could use a key punch machine, aka the first iteration of a keyboard. The 1800s were a period where the theory of computing began to evolve, and machines started to be used for calculations. But the 1900s is where we begin to see the pieces of this nearly 5,000-year puzzle coming together, especially between 1930 to 1950. In 1936, Alan Turing proposed the concept of a universal machine, later to be dubbed the Turing machine, capable of computing anything that is computable. Up to this point, machines were not only able to do certain tasks that the hardware was designed for. The concept of the modern computer is largely based off Turing's ideas. Also starting in 1936, German engineer Konrad Zuse invented the world's first programmable computer. This device read instructions from punched tape and was the first computer to use Boolean logic and binary to make decisions through the use of relays. For reference, Boolean logic is simply logic that results in either a true or false output, or when corresponding to binary, 1 or 0. We'll be diving into Boolean logic deeper later in this video. Zuse would later use punch cards to encode information in binary, essentially making them the first data storage and memory devices. In 1942, with the computer the Z4, Zuse also released the world's first commercial computer. For these reasons, many consider Zuse the inventor of the modern-day computer. In 1937, Howard Aiken with his colleagues at Harvard and in collaboration with IBM began work on the Harvard Mark I calculating machine, a programmable calculator and inspired by Babbage's analytical engine. This machine was composed of nearly 1 million parts, had over 500 miles of wiring, and weighed nearly 5 tons. The Mark I had 60 sets of 24 switches for manual data entry and could store 72 numbers, each 23 decimal digits long. It could do 3 additions or subtractions in a second, a multiplication took 6 seconds, a division took 15.3 seconds, and a logarithm or trig function took about 1 minute. As a funny side note, one of the primary programmers of the Mark I, Grace Hopper, discovered the first computer bug, a dead moth blocking one of the reading holes of the machine. Hopper is also credited with coining the word debugging. The vacuum tube era marks the beginning of modern computing, the first technology that was fully digital, and unlike the relays used in previous computers, were less power hungry, faster, and more reliable. Beginning in 1937 and completing in 1942, the first digital computer was built by John Atanasoff and his graduate student Clifford Berry. The computer was dubbed the ABC. Unlike previously built computers like those built by Zuse, the ABC was purely digital. It used vacuum tubes and included binary math and Boolean logic to solve up to 29 equations at a time. In 1943, the Colossus was built in collaboration with Alan Turing to assist in breaking German crypto codes, not to be confused with Turing's Bombay that actually solved Enigma. This computer was fully digital as well, but unlike the ABC was fully programmable, making it the first fully programmable digital computer. Completing construction in 1946, the Electrical Numerical Integrator and Computer, aka the ENIAC, was completed. Composed of nearly 18,000 vacuum tubes and large enough to fill an entire room, the ENIAC is considered the first successful high-speed electronic digital computer. It was somewhat programmable, but like Aiken's Mark I was a pain to rewire every time the instruction set had to be changed. The ENIAC essentially took the concepts from Atanasoff's ABC and elaborated on them in a much larger scale. Meanwhile, the ENIAC was under construction in 1945. Mathematician John von Neumann contributed a new understanding of how computers should be organized and built, further elaborating on Turing's theories and bringing clarity to the idea of computer memory and addressing. He elaborated on conditional addressing or subroutines, something Babbage had envisioned for his analytical engine nearly 100 years earlier. Also, the idea that instructions or the program running on a computer could be modified in the same way as data and decode them in binary. Von Neumann assisted in the design of the ENIAC successor, the Electronic Discrete Variable Automatic Computer, aka the EDVAC, which was completed in 1950 and the first stored program computer. It was able to operate over 1,000 instructions per second. He is also credited with being the father of computer virology, with his design of a self-reproducing computer program.
And it contains essentially those things which the modern computer has in it, although in somewhat primitive form. This machine has stored program concept as its major feature, and that, in fact, is the thing which makes the modern computer revolution possible.
At this point, you can see that computing had officially evolved into its own field, from mechanical to electromechanical relays that took milliseconds to digital vacuum tubes that took only microseconds. From binary as a way to encode information with punch cards, to being used with Boolean logic and represented by physical technologies like relays and vacuum tubes, to finally being used to store instructions and programs. From the abacus as a way to count, to Pascal's mechanical calculator, the theories of Leibniz, Alan Turing, and John von Neumann, the vision of Babbage and the intellect of Lovelace, George Boole's contribution of Boolean logic, the progressing inventions of a programmable calculator to a stored program fully digital computer, and countless other inventions, individuals, and groups, each step a further accumulation of knowledge. While the title of the inventor of the computer may be given to an individual or group, it was really a joint contribution over 5,000 years, and more so between 1800 to 1950. Vacuum tubes were a huge improvement over relays, but they still didn't make economic sense in a large scale. For example, of the NEX 18,000 tubes, roughly 50 would burn out per day, and a round-the-clock team of technicians would be needed to replace them. Vacuum tubes were also the reason why computers took up the space of entire rooms, weighed multiple tons, and consumed enough energy to power a small town. In 1947, the first silicon transistor was invented at Bell Labs, and by 1954, the first transistorized digital computer was invented, aka the Trudic. It was composed of 800 transistors, took the space of 0.085 cubic meters compared to the 28 the ENIAC took up, only took 100 watts of power, and could perform 1 million operations per second. Also during this era, we begin to see major introductions on both the hardware and software aspect of computing. On the hardware side, the first memory device, the Random Access Magnetic Core Store, was introduced in 1951 by J. Forrester. In other words, the beginnings of what is now known as RAM today. The first hard drive was introduced by IBM in 1957. It weighed 1 ton and could store 5 megabytes, costing approximately $27,000 per month in today's money. On the software side is where a lot of major innovations and breakthroughs began to come. This because computer hardware and architecture was beginning to become more standardized, instead of everyone working on different variations of a computing machine. Assembly was the first programming language to be introduced in 1949, but really started taking off in this era of computing. Assembly was a way to communicate with the machine in pseudo-English instead of machine language, aka binary. The first true widely used programming language was Fortran, invented by John Baucus at IBM in 1954. Assembly is a low-level language, and Fortran is a high-level language. In low-level languages, while you aren't writing instructions in machine code, a very deep understanding of computer architecture and instructions is still required to execute a desired program, which means a limited number of people have the skills, and it is very error-prone. Also in the early to mid-50s, to compile code back to machine code was still an expensive and time-consuming process. This all changed with Grace Hopper and the development of the first computer compiler. Hopper, if you remember from earlier, also found the first computer bug. This allowed for programming of computers to become more affordable and nearly instantaneous instead of the time-consuming process of writing code in assembly and then manually converting it back to machine code. As a side note, Hopper assisted with the invention of another early programming language, COBOL. This era marks the beginnings of the modern computing era, and where the exponential trend of computing performance really began. While transistors were a major improvement over vacuum tubes, they still had to be individually soldered together. As a result, the more complex computers became, led to more complicated and numerous connections between transistors, increasing the likelihood of faulty wiring. In 1958, this all changed with Jack Kilby of Texas Instruments and his invention of the integrated circuit. The integrated circuit was a way to pack many transistors onto a single chip instead of individually wiring transistors. Packing all the transistors also significantly reduced the power and heat consumption of computers once again, and made them significantly more economically feasible to design and buy. Integrated circuits sparked a hardware revolution, and beyond computers assisted in the development of various other electronic devices due to miniaturization, such as a mouse invented by Douglas Engelbart in 1964. He also demonstrated the first graphical user interface. As a side note, computer speed, performance, memory, and storage also began to iteratively increase as ICs could pack more transistors into smaller surface areas. This demonstrated by the invention of the floppy disk in 1971 by IBM, and in the same year DRAM by Intel, to list a few. Along with hardware, further advances in software were made as well, with an explosion of programming languages and the introduction of some of the most common languages today, BASIC in 1964 and C in 1971. As you can see from throughout this video, computing since the 1900s has evolved at an increasingly fast rate. Thus, in 1965, led Gordon Moore, one of the founders of Intel, to make one of the greatest predictions in human history. Computing power would double every 2 months at low cost, and that computers would eventually be so small that they could be embedded into homes, cars, and what he referred to as personal portable communications equipment, aka mobile phones. We now refer to this as Moore's Law. Here are some charts to further illustrate how fast computing was evolving and what Moore based his predictions on.
One of my colleagues called this Moore's Law. Rather than just being something that chronicles the progress of the industry, it kind of became something that drove the progress of the industry. A tremendous amount of engineering and commitment has been required to make that happen, but much to my surprise, the industry has been able to keep up with the projection.
At this point, the video has come to a conclusion. I'd like to thank you for taking the time to watch it. If you enjoyed it, please leave a thumbs up, and if you want me to elaborate on any of the topics discussed or have any topic suggestions, please leave them in the comments below. Consider subscribing to my channel for more content, follow my Medium publication for accompanying blogs, and like my Facebook page for more bite-sized chunks of content. This has been Encore, you've been watching Singularity Prosperity, and I'll see you again soon.
Let's have a brief recap of the information that we have just learned from the video. For this, read from page number 5 to 7 from your textbook. Memorize the various forms of early calculating devices such as abacus, Pascaline, Napier's bones, Leibniz calculator, Jacquard loom, difference engine, and analytical engine. Highlight the contribution of Pascal, John Napier, Leibniz, Jacquard, and Charles Babbage in the field of computers. Now students, can you tell me which was the first calculating device used by the people? You have just read it in your textbook. That's good. It was abacus. Do you know what an abacus is? It was the first calculating machine. It was invented in China about 5,000 years ago. It consists of rectangular frame with vertical rods and beads. The beads on the rods are allowed to slide up and down. This machine could only add and subtract items. Now students, can you tell me which was the second machine that was used by people to count? Yes, it was Pascaline. You know who invented Pascaline? Yes, it was invented by Blaise Pascal, a French mathematician in 1642. Blaise Pascal was only 17 years old when he invented this machine. He invented this machine to help his father in doing some official job. Pascaline was used to add and subtract numbers. The disadvantage of this machine was that it could not perform multiplication and division. Now students, do you know who improved the calculating devices for people to do multiplication and division? Yes, it was Napier's bones. John Napier invented Napier's bones. It could perform addition, subtraction, multiplication, and division. Leibniz calculator was invented by Leibniz. It was used to perform multiplication and division functions, and it could even calculate complex numbers. It was improved form of Pascaline. Jacquard loom. Jacquard loom was invented by Joseph Marie Jacquard. It was the first machine to use punched cards to control the sequence of operations. Now let's see what is a punch card. A punch card is a piece of paper with holes in it. It contains information for doing calculations. Difference engine and analytical engine. Can you tell who invented difference engine and analytical engine? Yes, you might have read it about him in your book. Of course, you are right. These two machines were invented by Charles Babbage. He is called father of modern computer because of his contribution in the field of computers. This is the picture of difference engine and this is the picture of analytical engine. Now let's see if we can answer the following questions. You can use your textbook as reference guide and write your answers in loose sheets. You can show your answers to your computer teacher later. Which calculating device was invented in China and when? Abacus, about 5,000 years ago. Who was Blaise Pascal? He was a French mathematician who invented Pascaline. Now let's have a brief recap of the topics and things that we have covered in this lesson. Abacus, Pascaline, Napier's bones, Leibniz calculator, Jacquard loom, difference engine, and analytical engine are early forms of calculating devices. Abacus was invented in China about 5,000 years ago. Pascal, a French mathematician, invented Pascaline. John Napier invented Napier's bones. Leibniz invented Leibniz calculator. Joseph Marie Jacquard invented Jacquard loom. Charles Babbage is called the father of modern day computer. Charles Babbage invented difference engine and analytical engine. Now try to answer these questions. Write the answers in loose sheets. Show your answers to your computer teacher. Which is the first calculating device? Who is known as the father of computer? Which device consisted of boards and a set of rods? What is punched card? Students, I hope that you have enjoyed this lesson. We shall meet in the second lesson on the same chapter. Till then, take care of yourselves and Allah Hafiz.